Welcome back to Math Dogs. If you're new to the channel, please comment, like, and subscribe. If you have any questions, please comment down below. Problem number 7 says, solve the following. 4x plus 14 is greater than or equal to negative 2 times x plus 5. And so this is an inequality, and the process is very similar to solving an equation, except if we multiply or divide by a negative value, we have to reverse the inequality symbol or flip it over. And so I'm going to look at the left side and the right side. The left side of this problem is already simplified as 4x plus 14. However, on the right side of the problem, I have a distributive property. So I'm going to multiply negative 2 times x plus 5 first. So I would have 4x plus 14 already simplified on the left-hand side is greater than or equal to negative 2 times x is negative 2x, and negative 2 times 5 is negative 10. Now I have to put all my variable terms on one side and my number terms on the other side. I like to keep my variable term positive. However, in inequalities, I kind of like to keep my variable terms on the left side, and so I can read it from left to right. You don't have to, but it's just easier as we read from left to right to see what the actual inequality is. So I'm going to add the opposite of negative 2x, which is positive 2x on both sides, in order to eliminate the variable term on the right. So 4x plus 2x is 6x plus 14, and that's going to be greater than or equal to negative 2x plus 2x is 0, and 0 minus 10 is negative 10. And now I just have to isolate my variable term 6x. So I'm going to take the opposite of positive 14, which is negative 14 on both sides of the inequality. 14 minus 14 is 0. 0 plus 6x is 6x. And that is greater than or equal to negative 10 minus 14 is negative 24. Last step would be to divide both sides by 6 in order to make the coefficient equal to 1. Since I'm dividing by a positive value, I'm not going to reverse the inequality symbol. Even though the 24 is negative, I'm not dividing by the negative, and so the inequality symbol remains as a greater than or equal to. So 6 divided by 6 is 1x, and x will be greater than or equal to negative 24 divided by 6 is negative 4. So x is greater than or equal to negative 4 in algebraic form. I can also represent that graphically on the number line. I have negative 4. I have a greater than or equal to. The or equal to part means I'm going to have a closed-in circle. And I want all the values greater than that, so that will be graphed to the right. And so x is greater than or equal to negative 4 in algebraic form, and x is greater than or equal to negative 4 in a graphic form on the number line.